What's up, guys? What's up, everybody? Thanks for showing up. Really nice to see you all. Let me share my screen here. Yeah, cool. So I've got the chat up. So feel free to throw any comments, questions into the chat. And I didn't plan for an hour and 15. So I mean, this is gonna be a little tighter. So I will have plenty of time if you've got questions. If you want to go back, go over something in particular, I'm happy to do that. So yeah, I'm a faculty member at A&M. I've been here since 2007. Recommender systems is a topic that I've been really interested in probably for the last 5, 6, 7 years. And kind of one of the big kind of inciting instances was in 2015. I took a sabbatical and went to Google, and I was thinking I was going to work on kind of the search side of things. But then it turns the sort of recommendation was kind of where all the action was. Okay. And so this is back when the Play Store was really blowing up. And so just like a lot of opportunities to work in the recommender space. And so I've done a ton of research in this area. And so what I kind of call today, it's recommender systems, but it's kind of recommender systems. Let's call it like a guided tour. Okay. So I'm going to try to walk you through a little bit of the history, give you some pointers, give you foundation, so that when you walk out of here, you'll have some understanding of kind of where you can go next to get deep into it, and also to kind of understand kind of where you fit and where kind of the problem space is, and where kind of the tough parts are. But before I do that, I want to kind of get this to work. Before I do that, I want to go back in time just a little bit. So actually back in 2012 and 2013, my lab hosted a data-driven hackathon, which we thought we had the greatest name, which we'll license out to you guys, Coding Gig, trying to lean into the whole gig'em thing. And you can just see the prizes we had, right? We had some iPad minis, some Chromecast, stuff like that. And it was a huge amount of effort and energy, and it was basically just my lab that ran it. So some grad students, me, a few people. And this is what it looked like. This was over in HRBB, if you know the building, the big 124. This is on a Friday night, I think. I think maybe we had 40 people. So just for me to think about kind of where we were then and to where we are now, and like the fact that there are hundreds of people participating in the Datathon, I just want to kind of throw my hands up and just say congratulations on everyone on an amazing event so far. Big respect to all the participants. Special thanks to the organizers. It's an amazing job. I could never have foreseen that this was possible. And what's even better is I don't have to do any of the hard work. So thank you to all the organizers and everybody. I think it's amazing. And I imagine the prizes and the sponsorships and the opportunities to kind of build teams and to do something cool are like exponentially better than kind of our lame-o stuff back in the day. But anyway, if you do like that name, Coding Gig, or our logo, we're happy to discuss that. Okay, I'm going to talk about recommender systems. And I think after the talk, I'll drop these slides in Discord, or someone can help me on what I should do with that. So you'll get all these links and everything later on. And so what I'm not going to do is I'm not going to walk you through a bunch of kind of code examples, because it turns out, there are a bunch of really, really, really nice libraries that already exist that have very nice documentation, and that if you went and spent an hour on any of these, right, you could basically install and start running your own recommender pretty fast. And what you'll see is a lot of them implement the methods that we're going to talk about today. So what I want to do today is kind of give you the foundation of kind of core methods in recommendation. And then when you go and look at Spotlight or Surprise, you may not understand kind of the syntax of those particular libraries, but you'll know kind of conceptually where everything fits together. I also dropped in this nice survey on collaborative filtering. It's really long, but in my mind, it's kind of written to a very it's technical, but it's written in a kind of very somewhat easy to read kind of, sort of, let's call it advanced undergraduate level. You should be able to knock it out. There's also like just sort of a pretty brief treatment in this book. And if you're at A&M, you should be able to access it for free. And towards the end of the talk, I'll mention some future directions. And so if you're really kind of inspired and like what's happening, cutting edge right now and today, there are a bunch of sort of top computer science conferences, and I list a couple of them here. Maybe you don't know what these acronyms stand for, but if you were to Google for them, you'll find like basically, what's happening right now today, all the hot stuff. And what's really exciting to me is a lot of the cutting edge research now is people are posting links to their GitHub. And so you can go get the code. It may not be like, bulletproof code, but at least it gives you access to it and you can try it out on your own. Okay. So like I mentioned, kind of in ye olden days, I was really interested in search, right? And so like I was interested in Google and kind of how search works. And so you can imagine, here's Google and we have a bunch of stuff. Okay. In this case, they're videos. So maybe this is like YouTube search or even Google's video search. So you've got all this stuff on the right. You've got your users here. Let's call these our items. And when you think about search, right, we think about a particular user, right, kind of has some sort of information need in mind, like something that they care about. And typically they're going to then express that, as a query, send it off to Google. Google is going to do something magical here and then give me back, my 10 blue links of my results, right? And so from the search side, the idea is you have something in mind that you care about and that you're looking for, right? So it may be, I'm looking for the latest trailer for some movie. So I query for the title of the movie and then I get back my result, okay? And so obviously, I think most of you know this, but like, if you look at recommenders, right, it flips that around, which is there is no query, right? So if you look in the recommender space, right, we still have users, we still have lots and lots of items, but the point is the user is not formulating some query and sending it to some service. Instead, there's some black box in the middle that is somehow trying to take all of this stuff, right, and guess what we should send to the users, right? So we miss that signal of the users telling us what they want. And instead we have to somehow infer that and make our best guess at sort of just telling you, this is what I think you want, okay? And so as a result, because in the recommender space, you have so much less like explicit signal from the user, right? Maybe the user's clicked, maybe you have some of their behavioral indicators, but they're not just telling you, tell me, show me the trailer, right? It's almost, at one point that was a really hard problem, right? But now it's like almost just trivial, like show me the movie trailer, here it is, okay? Recommenders, we don't have that signal, okay? And as a result, that's why I think it's such a cool space and a really, really challenging space, okay? So we have users, we have items, and typically we think about having not just a few items, but lots and lots of items, okay? And so I'm showing you some examples of, maybe some YouTube videos or some movies, right? But items can be basically anything. So examples where you might have other kinds of items that you would want to recommend, right? So you have like, songs, right? And so like that's Spotify, right? Have lots and lots of songs, just recommend me things to listen to. If you consider just books, right? There's things like Goodreads, Amazon, whatever, Barnes and Noble, other kinds of services can recommend books. I'm looking in the chat also, please, as I ask, sometimes these are sort of rhetorical questions, but if you want to get ahead of me and just throw something in the chat, do that and that'll help me so I don't forget stuff. But like we have songs, we have books. You can think about like, let's say Facebook post, right? To drop into my Facebook news feed, right? And so in that case, if you think about it, right, at any time, there are literally thousands and thousands, if not hundreds of thousands of posts that Facebook has to figure out which of these am I going to then pick just a few of them to put in your feed to show to you, right? And so if you talk about Facebook posts, but kind of any sort of social media feed, which ones do we show, okay? You also have obviously things like jobs, right? So if you went to some kind of job search, I don't know what people use these days, Indeed or ... What jobs do I show you? But you can also flip it around and not just think about recommending jobs to you, right? Because we think about the user as often kind of the, all these examples I'm giving you here are kind of like consumer facing recommenders, right? But you could think about it also from, let's say, so this is what the items are, but suppose the user was some company, a company recruiter, right? And so the items might be, let's say resumes or candidates. Okay. And so then I sort of flipping it around, which is not saying sort of facing towards you, but for a company recruiter saying like, look, I've got hundreds or thousands of applicants for a few positions. is there some way, something in the middle, some recommendation algorithm can help me focus on the few resumes or candidates that I should, okay? So these are just a few examples. You also see recommenders in personal health. You see it in all sorts of places, okay? It's not just movies, super cool, super valuable, okay? So why do we care about recommenders, right? So I think most of these you can think of as quite familiar to you, right? Helping you discover new content, right? So you can imagine you're on some platform and the recommender might show you a little box to the side and it lets you discover things you didn't even know about, right? It might help you find things that you were already looking for. And so this is one of those things, you know, if you're on Netflix and you're watching a movie, right? And like, I don't want to have to go look for the sequel to the movie. It would be nice if it was just popped up right next to it, right? Oh, okay, yeah, that's the thing I was looking for, obviously, right? I mean, you can even think about it in terms of, you know, sort of playing the next episode of a show, right? At one point that logic wasn't in there and you would have to sort of do some effort to find the next show. So the idea there is I already knew what I wanted and the recommender is just sort of queuing it up for me. A little different is you might discover things that go together. And so you see this on some, particularly like on fashion sites or even on Amazon, right? So the idea is I'm looking at a jacket. So then you might recommend to me, not other jackets, but you might recommend to me, you know, some nice pants or shoes or something that complements the thing that I'm looking at. And so the relationship is a little bit different from saying like, oh, you liked Harry Potter 1, here's Harry Potter 2. It's saying, oh, you like this thing, here's a thing not like that thing, but a thing that goes with that thing. Okay, so different kinds of relationships you can have in there. Of course, personalizing user experiences. This is again, like if you give your thumbs up and your thumbs down in your news feed, right? You're giving some feedback that can personalize the experience on Facebook, or if you're thumbing up and thumbing down tracks that you listen to on some streaming service, it can personalize. And so later on, you have different kinds of songs to listen to. And of course, identifying things you like and so forth. Okay, so go back to our picture, right? So we have, again, our users, we have our items, and in the middle, there's some sort of recommendation, you know, let's call our algorithms, sort of our engine, kind of the thing that makes it all work, okay? And so the question is kind of like, what's in there and how does that really work? And what I want you to notice, though, is you can basically build, you know, people have been building recommendation algorithms from kind of before, you know, let's say before the internet was invented. And you say, well, how is that possible, right? So you can always have hand curated or editorial recommendations. And so for those of you who want to build a recommender, you have some you have some data, you're building some service, and you want to start recommending it to your users. And you're thinking, I've got to build some like fancy algorithm. It's like, no, you can just actually pick out and just have like your hand curated best recommendations. Okay. It's like in the olden days, it would be like if you looked in the newspaper and like there was Roger Ebert was a guy who reviewed movies, and you look in the newspaper and Roger Ebert would tell you which movies were good or not. Okay. And so, okay, or, you know, again, we don't read the newspaper anymore, but the idea is this is basically, you know, this is like, you know, my top 10. Okay. There's no real algorithm there, but that's a recommendation. So don't get lost and think that recommendations have to be fancy algorithms. It could just be, these are my top 10, you know, here are my favorite new tracks that were released this year, done, okay? You can also do very like simple aggregates. This is like, you know, what were the top 10 most listened to tracks, right? That's a recommendation and you can feature that on your platform. You know, what were the top 10 most listened to, you know, what were the top let's say the top 10, you know, whatever, like most viewed, whatever. So there's no algorithm there, right? It's very simple. You just tell me the top things, show them to me, done. So we have a point here about people also bought. That's in terms of how we might build a recommender, right? Yeah. So we're going to kind of get to that in just a second. Yeah, that's a really good point. But what I want to get at is like the picture I showed you here, like all the users are sort of clumped together, right? So it's like we process all this stuff and then we're pushing out, you know, let's say some list of recommendations. Okay, but really the users aren't clumped together. Really, we want to have them personalized and tailored to individual users. Okay, and so the right picture is this, right? So they have all this stuff and each user, right, is getting a different, you know, again, it could be a list of things or whatever. Each one's getting their own personalized recommendations. And so like this sort of editorial top 10, or even this most popular or most viewed, is not tailored to the person. So that's like kind of the real magic when people talk about recommendation algorithms, is how do we make it personalized? How do we really do that? Okay. I'm going to skip over this. This is some sort of, yeah, we'll come back to this later. Kind of my rules of thumb about this space. Now, we're going to talk about some actual methods in a second. Before we do that, I want to give you some further complications that makes your life difficult, okay? So imagine you've done some startup, right? You have some service, you have some app, you have some users, okay? And you want to now start pushing things to your users, right? So what kind of feedback do you have? So when I say feedback, like kind of in old days, you might have actual ratings, okay? Or like stars. And yes, you can still find on Amazon, there's still star ratings, right? But people are kind of reluctant to give ratings or stars, okay? And so we call explicit. It's explicit feedback. You also have implicit feedback. That's no one told me like this is the stuff I like. All you know is maybe you have some logs of what people clicked on, what people viewed, what people interacted with, okay? And so implicit feedback is tricky, right? Because you might click on something and it doesn't mean you like the thing, right? So be very careful in how you deal with that. Another issue is like, what kind of user base do you have, right? Is it like a mature kind of not, sort of static user base? That's one version of the world. Or are you constantly ingesting new users? And so think about it. If you have new users, right? Kind of, it's hard to, where to build like a user profile, right? It's really hard to do that. If you have new users, you don't know anything about them, okay? If you have a platform where everyone's been around for a long time, you might have like kind of a rich user model. Oh, I know this, this person's really active in the morning and they like this kind of music. Easy. New user, real challenge. And so if you kind of blow recommendation for all those new users, you may have them just pass through and they don't come back, right? You don't grab them. Related to that, are the items that you're serving up kind of fixed, or are there always new ones being added? So if you're building a song streaming service, there's always new songs, right? But if you're just recommending, music to old people like me, all I want to hear are my classics from the 60s and 70s. So that music's not changing, okay? So it's a totally different environment, changes everything about your recommendation, okay? And so the point I'm trying to raise all this stuff is because I don't want you to think that like, oh, all I got to do is sort of learn this one magic algorithm and I've solved it, okay? It turns out like there's lots of kind of sort of edge cases. There are lots of sort of design points that are going to change like how you want to solve it. Last little point is, how do your users engage with the thing, right? So like this single right item. So for a while, there's a thing called Google Now. I think that's what it was called. You can imagine a service like on your phone, which is, I need to optimize, like if someone looks at my phone, what is the one thing I'm going to tell them about right now? Okay. So I got a recommendation of, is it to call someone? Is it to tell me the weather? Is it to use a certain app or whatever? Whatever that recommendation is, you're optimizing on like that top one experience. Like that first, whatever I post better be good, or people are going to hate it and the service is going to die, which is a totally different like environment than, I'm on some platform, even like Amazon or Book Reads, where I'm just kind of like goofing around and just sort of looking around and enjoying my life, right? It's not like critical that you get the recommendation exactly right. And so as a result, kind of what your optimization criteria could be totally different. Boom. Okay. Let's talk core algorithms. That's why you're here, right? You're all data scientists. Core algorithms. These are kind of 4 classics. I don't have time to talk about all of them, but I will give you some depth about some of them, okay? Got our collaborative filtering, content-based methods, latent factor models. What does that even mean? Mixture models. Mixture models are easy. What does that mean? It means combine the ones before in some way. Okay, mix them up. Okay. So let me just I'm going to give you this in one slide. And then I'm going to give you a little bit more on these other 2. Okay. Content-based methods. So go back to our Facebook These are Facebook posts. This is one user, okay? Content-based methods are, I'm actually going to look at the content of the stuff, in this case, the post, okay? Separately, I need to know what kind of stuff, what kind of content this user likes, okay? So kind of one classic way to do that would be for this user, basically, can I build a user profile? Okay, so what does user profile means? Well, for example, let me look at the last, let's say 10 posts you interacted with. Okay, and it could be 10 posts, it could be 100 posts, it could be some sort of exponentially decaying, it's whatever. But if I look at the last 10 posts that this person interacted with, and then typically what I want to do is I want to find some way to represent that user, based on that history of items. Okay, oh, you clicked on some A&M content, you clicked on some football content, you clicked on some data content, okay? And so typically what you're going to end up doing is you may generate some kind of vector representation that captures this user's interest, right? And sort of on a first pass, it could be each element could be like a specific word, right? So like the word Texas occurred 3 times in all of those posts, and the word Aggie appeared 4 times, and the word data occurred 5 times. And that gives me like a simple representation, right? And then what I can do is on the other side, I can look at all of the posts of that are basically like, when you logged into Facebook, here are the 10,000 posts from your friends and kind of 2 hops away from you in the last day, right? Now I can try to find some similarity between this user profile and let's say, a post, and then I can rank all the posts. Okay. That's like a very kind of heuristic, kind of hand-cooked one. Okay. So of course you don't have to represent each user by some aggregation of the words. You could do something fancier, right? So you might have some neural network, you might do some sort of embedding-based representation. Cool. Similarly, you might represent the post in kind of a fancier way, okay? And you might also do the matching, not with some similarity function, but you might actually cook up some machine learning where you try to learn a matching function from one to the other, okay? But the idea is the same, which is we're gonna actually look into the content and do matching based on the content. So what about time spent looking at certain posts? Oh, that's a great point, yeah. So yeah, you can do a lot of stuff to like weight them, right? So you might say, oh, okay, this person dwelled on these kinds of posts more than these other posts. So then that can become a factor that can then be go in sort of the function that you use to build the user profile. Absolutely. And you can do lots of other tricks, right? You can say these posts aren't over here. They're not just sort of all equal, right? The posts might be, some of them are from your close friends, people you interact with a lot. Some are from people a couple of hops away. Some of them are from celebrities. Some of them are from companies. And so they all, it becomes a really complex problem on how you want to assign kind of different weightings to different posts, as well as to sort of aggregate the content in the post and represent it. But yeah, you're on the right track. I mean, it's like, it gets super complicated. Boom. Okay, that's content-based. What I really want to talk about is kind of give you this sort of guided tour of recommenders, okay? So we're going to go from the 1990s, so before you were even born, most of you, all of you, to the 2000, yeah, we'll get to 2017 or 18. We'll get to the modern era, okay? But what I want to show you is that like some of these ideas seem old to you, but they're still like rock solid foundations of the stuff we're doing today. And in fact, this area, it doesn't move as fast as you might think it is. It does, okay? It's kind of, it's not glacial, but the idea is sort of a few big ideas hit. And so long as you learn those big ideas, you're gonna be okay. So you go back in time, right? So kind of web comes out in the early 90s. Amazon is like 94, okay? And so what you start to see is the development of, wait a minute, we're suddenly no longer constrained by brick and mortar shops and like whatever, I can fit in my shop, to you have internet consumers who are sitting at home and now they have access to, every book that was ever published. Okay. So all of a sudden this started to drive this research and this kind of practical, like, how do we actually take all those, millions of books and figure the right ones to show to people? Okay. So let's talk collaborative filtering. So this is like OG, original, like deep, cool recommendation algorithm. Okay, and I'm going to make some assumptions right now, which is we have explicit feedback, which is I actually have ratings, and I'm going to assume my users and items are fixed. So nothing is changing. Of course, this is not realistic, but so we're going to start. I got 5 users. I've got 5 movies. 1, 2, 3. I got 6 movies. I got 6 movies and 5 users. Okay. And so this is my classic, like, these are my users. These are my items. And each one of these is a rating. Okay. And let's say it goes from 1 to 5. And I've got a bunch of empties, right? And so we're going to try to figure out is how do we fill in the blanks? Because what we'd like to do is figure out, are there users who would we guess highly rate a movie? Then we can recommend that movie to the user. Okay. So for example, we could cook up right now lots of ways to guess how could we guess what Alice would rate Dumbo, right? I'm actually going to look in the chat right now, and someone throw in there like, how would you guess the rating that Alice would give to Dumbo? And you don't need to be fancy. But tell me how you get it. I like it. We already have a guess, 2. Where did 2 come from? Okay. 3 to 4. Okay, tell me, how are you coming up with those numbers? Okay, how do I come up? Newer movies have higher values. Dumbo is old, hence Dumbo gets old or gets low rating. Okay, great. You learned something maybe. New, good, old, bad. Hence, hence we give it a 2. Okay, that's a method. We could take the average of all the movies. Okay, done. We could put in, we could just guess a random number. Why not? Who cares? Oh, maybe we could look at the relationship. Somehow I know Dumbo is like some other movie. So maybe I could say, well, I know something about Dumbo. It's similar to Avatar because they're both animated. And so I should give it a high rating. Okay. Yes, you can do that. So it turns out, yeah, there's lots of ways you can attack this problem. Okay. So what collaborative filtering does is it has a pretty simple intuition though. It says, look, we have lots of users. So basically we're going to say, I like items that people like me like. Okay. So let's go back to this example with Dumbo, right? So we said Alice. We say, now who's like Alice? Well, we could know some sort of metadata about Alice or some user profile about Alice, and we know something about where she grew up and where she went to college and all that. But right now, all we know is this ratings matrix. And we could say, oh, okay, yeah, Alice and Bob, they both liked Avatar. They both liked Black Panther. Bob did not like Dumbo. So we can probably guess something low. We're going to guess Alice probably also would not like Dumbo. Okay. So this is exactly the intuition of collaborative filtering. Basically, for every user, find other users who are like that person, and then somehow aggregate their rating and give it to that person. Okay. Super simple idea, but there's some subtleties there. So let me show you kind of the actual method that we just talked about. Okay. I give you a user I think it was at Alice. Okay. Now we want to find n users. So already, right? That's like a parameter, like is n 1? We just did 1, but n could be, it's not just, by the way, it's not 5 by 6, right? It's not 5 by 6. It's really, this could be 100K, this could be 100K. This could be, 10 million. So this matrix in theory, you're not ever going to actually build a full matrix, right? But it could be this sort of ginormous matrix, okay? So we need to find the n users who are similar to user I. So that's a parameter. How many? We need to figure out how do we measure, right? How to measure similarity. Like what means, how do we know that they're actually the same? And then we have to somehow aggregate the ratings that all those other users gave and then give it back to Alice. So this last step is kind of like how to aggregate those n ratings. And we just did a very simple example, which was we said, okay, given a user Alice, find the one user who's similar to Alice. How do we measure that? Well, we used I mean, I think we kind of used the Manhattan distance or maybe Euclidean distance to measure that. It was small. And then how did we aggregate it? Well, right now we just took the number and posted it. Okay, that was how we did it. But in practice, right, there's a sort of a lot of kind of key points you have to make. Okay, so how do we measure the similarity? Well, there's a lot of ways. In collaborative filtering, one of the popular ways is using what's called Pearson Correlation coefficient. You could use, I'm just going to write these down. So if you go into one of those libraries later, Jacquard, you could use cosine, you could use Euclidean distance. But Pearson correlation is very popular. And you actually don't sum over all of them. You sum over all items rated by user X and Y. So basically you look at all of the ratings they have in common, okay? And you can use this, and this is going to output kind of a correlation between the two users, okay? And again, where the representation is just by row, right? Just sort of the ratings, whoops. You know, you just look at the ratings by row, and you can actually use the Pearson correlation. I'm not going to go into the details of all this, but I'll leave that as an exercise, okay? The second step is how do we aggregate? So we can use that, okay? Then we have to aggregate the ratings. So assume I actually did it with Alice, and assume we had like hundreds of thousands of users. And let's say I find the 5 closest users to Alice, and for Dumbo, okay? And imagine their ratings are 1, 2, 1, 5, 3. What rating, how do I aggregate those ratings to give a single rating to Alice? Okay, how do I do that? You're like, Cav, I'm no dummy. I'll take the average, okay? And you can do that, okay? So we'll take the average of those numbers, right? I found 5 people like Alice. This is the ratings they gave to the thing. I'll give you the average, okay? Well, I don't like the average. Maybe I'll do the median, okay? Oh, actually, because I found the 5 closest users, I know how similar they are to Alice. So I could do like a weighted average by the similarity, right? So I kind of weight, maybe the 1 is by someone really like me, and the 5 is by someone not as close to me, okay? These are design choices you got to make, okay? All right. That was what's called user-user collaborative filtering. Take Alice, find who's like Alice, okay? Guess what? There's something called item-item collaborative filtering. You're like, Cav, what? It's like, we're not going to go row-wise, we'll go column-wise. So instead you can say, given, let's say, I have a really good example here, to be honest. Given election, what movie is most like election? So instead of doing row-wise comparison, you do column-wise, okay? So maybe I find out Fargo, okay? So that's called item-item collaborative filtering. And it's just like user-user, same deal. How many neighbors do I find? How do I aggregate them? Whatever. But now I can basically tell you, oh, if you liked this movie, here are movies I can show you like that movie. Okay. So this is the 90s. People are building this stuff out like crazy, okay? Oh, yeah. Actually, I'm gonna skip this. It's like, how do you measure the quality of this stuff? Don't worry about that. Okay. So then what happens is, so no joke, literally like into the early 2000s, mid 2000s, people are still taking those item-item collaborative filtering, user-user collaborative filtering, and squeezing them and trying new tricks and so forth, okay? Did I mention that I had a COVID test today? That's true. Still waiting on my results, so I'm glad I'm not with you in person. I got a cough. I got a dry cough. It's frightening. We're in the mid 2000s, okay? And suddenly this atom bomb goes off in recommender space. So what happens in 2006 in particular? Does anybody know what happened in 2006 that like changed the world? That changed recommenders forever. Yeah, I know. Thank you. I hope I do feel better. So what happened Amazon was around already, but in particular what happened in 2006 was we had something called the Netflix prize. Okay. Slammo, what? The Netflix prize? Yeah, in 2006, this website is still alive. You can go check it out. There's still a leaderboard. You can go check it out. So for all of you, you're familiar with Kaggle and all these like data science competitions. This is like one of the original, hey, we're going to actually build a competition and have people all over the world enter it. Okay, this kind of predates all of that. It's like one of the sort of visionary ideas. So Netflix says, we'll give $1 million to whoever can improve upon our system the most. Okay. And so what they did was they released a boatload of data. So let me show you what they gave out. So this is like a shockwave. 100 million ratings. What? Because before we had like kind of small data sets, and we did the best we could to squeeze what we could. Yeah, I'm fine. Hundreds of thousands of users, lots of movies. Okay. So now we have data to train on. Okay. So now people all over the world, 2,700 teams, okay, get the data, build our own method. We make our guesses, okay? Then we send those guesses to Netflix, and they, right, if you're familiar with Kaggle, they go compare it to their held out test data that we don't know, and they send us back our number, okay? And I didn't get into the details of what this number is. This is like an error metric, but the idea is Netflix's error was 0.9514, and they wanted to see a 10% improvement. And the first team that got past 10%, they would then start like a 30-day clock, and that would end the whole competition. So after 30 days, you had to deliver your best possible result. The team that wins, wins, okay? I'm not gonna tell you the whole story of how this all ends, but you should, after this, go Google about Netflix prize and who won it and how they won it. But it is like dramatic. It came down to the last minute, okay? There's a question, which is, was overfitting an issue? So the issue here is, you could overfit, absolutely, but you were testing on test data that was truly hidden from you. And so you would never, if you overfit on your training data, right, you would do poorly on the test data. And so you would be rewarded for building not an overfit model, right? You'd be rewarded for building a model that would generalize to the held out test data that, again, you never saw. You only saw the error number, okay? Like this one number at the end. Okay. This is a shockwave. Why was it a shockwave? Because it was a boatload of data and it got a lot of people excited and they wanted to win the $1 million, okay? And so what came out of this was like a bunch of innovations that are still felt and we're still using today, okay? So, okay, and this is just kind of like what it looked like. Big matrix, I said like we have 17,000 movies, we have all these users, and some of it was hidden from you. You didn't know what it was, okay? So Netflix prize comes out, it's like a shockwave, okay? Big idea. They had kind of 3 big ideas. This is kind of like the winning teams. This is like the general approach that they took. Hey, there's our collaborative filtering. It's still around, okay? But they also had this other 2 things, okay? So let me show you what these are, and they're simple. It's super simple, and you can incorporate them into your models like right now. And they're already like built into those examples I showed you, those GitHub resources. Okay, global. Super simple, okay? Let's look at the overall deviations of users in movies. For example, suppose you have a movie, the average movie rating overall is, let's say, 3.7. And there's this new movie called Tenet, and suppose it's a little bit above average, that movie itself. But this user Zoe is a little bit negative, right? And she goes a little bit below. So the baseline estimate is just, 3.7 plus 0.5 minus 0.2. Yeah, I think Zoe will give it a 4 to Tenet. Done. Okay. Mathematically, all that means is we're going to say, yeah, I want to find the baseline rating for user X to item I. It'll just be this overall average, right? It'll be how much each user deviates from that average, and then how much each item deviates from the average. And that gives you a pretty good guess. And in fact, if you just use this, I believe you're performing almost as well as Netflix's whatever engineered solution they had, right? And there's no machine learning here, right? This is like just some averages and some addition, okay? In fact, you can do that on that example I already showed you, right? So if we're trying to figure out like what would Bob give to election, right? All you have to do is figure out like, okay, so what is the overall average? Can anyone add that up? 9, 10, 12. what is, I don't know, I can't add. Well, there's 18 ratings. Someone add up the 18 ratings and tell me what that is. Okay. But then we want to figure out what was Bob's rating and then what was Election's rating. Election's average rating is a 4.5. Bob's average rating was 9, 10, 11, 12. 12 divided by 3 is 4. And the overall is something divided by 18. Come on, someone add that up and tell me what it is. You make me add it up again? I got a COVID test today. I could be dying right now. I can't do addition. Come on, someone, it's like 60 something, I believe. Shit, I got to do it myself. 3.5. So whatever it is 3.5 is the average. Okay, thank you. 63, beautiful. So if you're trying to figure out what would Bob give to Election, well, it's 3.5 plus, okay, how much does Bob deviate? Well, Bob is a little more positive, right? So Bob gives a 4. So he's like a half a point above, okay? And Election itself is even higher, okay? So you could say 3.5 plus 0.5 plus 1, so what is that, 5? So my guess is a 5, done. And you could actually blow it up over the maximum and you can just cap it there. But that's like super simple, and you can do that, and you're almost doing as well as Netflix was doing in a commercial product in 2006. Okay, that should be shocking to you, right? Just by doing some summations and some divisions. Okay. Okay, but we also want to do sort of, I said, some local deviations, right? That's a collaborative filtering bit. So I just showed that example. I said Zoe's going to give Tenet 4, right? But we know Zoe did not like a related movie, Inception. So we may downgrade her rating to 3.5. Okay. How are we going to do that? That's just item collaborative filtering. Okay. So let me blow your mind here. So basically we can say, this is my guess for what user X will rate item I. Okay. That's that global baseline I just showed you. Okay. And this is not the perfect method. Here is one method, which is you basically say, these are these are items near or similar to item I that this user has rated before. And you just take the user's actual rating, right? That's the baseline rating. So you're basically saying, like, how far does this user deviate from the baseline? And then you do some weighting by the similarity between item I and item J. It's like a weighted average based on the similarity of the items, okay? You can look at this offline, I'll post these slides, but it's a way to basically do, this is essentially item collaborative filtering on the side that you can use then to update that baseline rating, okay? So, okay, you probably would like this movie according to our baseline estimate, but movies like it, you didn't like, so we'll penalize it, okay? And so for those of you who are kind of really like machine learning, like into machine learning and whatnot, okay, I'm not going to get into like all of that, but to give you the flavor of how this is all so beautiful is now I have a guess for what this user would give to this item, okay? That's my guess. It's just a guess. But remember, Netflix gave me like millions and millions of ratings. So what if I built some kind of optimization criteria just over the training data? If I took the training data and I chunked it into my own test and train, and then I could try to figure out how I can optimize some of these weights, the similarity function and whatever, to get the best choice, okay? And that, again, I'm not getting into the details here, just get you some excitement. You basically can decide, you can define some cost function, so, or a loss function for those of you who are into machine learning, right? And basically we said, look, that's exactly that predicted rating I just showed you. I replaced the S's with W's. These are just weights now. But now I also know the true rating because I have some trained test split. And so basically I can cook up, this is some error, right? And if I go into some kind of gradient descent or whatever kind of optimization I want to do, I can figure out the best weights for this to minimize the error. So in other words, I try to pick the weights such that my predicted ratings are as close to the actual ratings. If I can do that, right, I can basically like now have like a really beautiful model that I can then go apply on all that sort of the real test data that I don't know about that Netflix gives me, okay? So this is all happening in the late 2006, 7, 8, 9, 10, 11, okay? This is exciting, okay? So that's global, that's collaborative filtering, local. It's kind of like global, local, but there's sort of this thing in the middle, this factorization, okay? This is the third kind of big idea, okay? And this is basically like, this is latent factor models, okay? This is hot. This is super hot. You may also hear this called like matrix factorization. And so this stuff came out from this Netflix prize. I mean, the idea has been around forever, how to factorize a matrix, but to use it in this context, game changer, okay? And so what is this all about? So the idea is like, the global is like really big picture. It's like averages over all the movies, okay? The local, the item collaborative filter is very much like this specific movie and that specific movie. This regional like latent factor model is talking more at kind of this sort of in-between zone about almost like genres, if you're thinking about movies. Or the idea is there's sort of like some things are kind of alike, like these are sort of action movies, these are kind of adventure movies, and kind of grouping them that way. And again, like in kind of shorthand, what it does is it takes this big matrix here, it tries to decompose it into two smaller matrices. And so imagine this just has like, imagine this is just 2-dimension. This is 2-dimension, okay? And so the idea here is like, imagine, okay, let's say this is, so these are my users and these are my items. And I might have just like K latent factors. And the idea is like for user Alice, okay? So that's Alice. So here's Alice. This is Alice. So it's like saying like, look, this is Alice. Let's say, and this is Avatar, okay? And this is Avatar. And so it's basically saying like, user Alice lives in some latent, just sort of latent preferences. She likes kind of action and romance, okay? And then in the item space, it tells you Avatar, how does it live in the action and romance spaces, just those two. And if you just do like a simple inner product, you're gonna go back and recover the rating that Alice gave to Avatar and all the other movies, okay? So if you're not up on your linear algebra, no big deal, okay? I'm just going to show you this because it's like really exciting and like really powers a lot. So if you're not up on your linear algebra, you're going to want to learn this stuff because this is hot. Okay, this is great stuff. I'm going to skip all this because you don't care right now. Okay, all of that, no joke, that gets you into like 2015. Okay, and of course there's a lot of stuff going on. This is me kind of overstating it a little bit, but like if you can understand those basic ideas, you're basically just a few years ago, okay? And a lot of that stuff is like actually, it's built out, it's implemented, it's in production. Don't worry about it, okay? What's been happening basically the last 5 years? Can anyone guess? What's happened in the world in the last 5 years for basically everything computational? What is everyone losing their minds over and doing? Not just in recommenders, but in every space. I'm in the chat right now. Machine learning. Yes. ML is eating everything, and deep learning in particular. Boom, you guessed it. Okay, last 5 years. I mean, of course, machine learning has been around way before that. And of course, it's been used in recommenders way before that. Okay. But last 5 years, machine learning is eating up everything. And in particular, deep learning is eating up everything. Okay. And so we're using it, new ways to represent items and users, new pipelines, everything has totally changed, okay? So, but what I would get at is if you're gonna try to study this space, I wouldn't start on the deep learning end. I'd wanna start with these foundations because all deep learning is oftentimes doing is just going back and replacing kind of those basic ideas with sort of a more sophisticated, kind of fancier model, but ultimately is doing like the same thing. Okay. And I'll show you, like, in, I think it was 2015, like a very simple idea was autoencoder for recommendations, something called autorec. Okay. There's lots of these kinds of neural nets you can apply, but I'm gonna skip over this. Okay. Okay. So in with deep learning is kind of eating everything. Machine learning is eating everything. Okay. But I kind of cheated you, right? So I gave you kind of the one path, but I cheated you because everything I've been talking about is explicit ratings. That means like I've got like stars, or I got, you gave it 5 stars or you rated it 2. Okay. But in practice, we know basically nobody gives explicit ratings. I mean, you do, like, I guess if you use Uber because you have to, right? But if you don't have to, I don't know about you, like when I buy something from Amazon, they spam me forever. Like, will you please rate this thing? And I've been using Amazon forever and I've never rated anything. Okay. And so what happens is, right, by and large, people don't give explicit ratings. And so if you actually are building a recommender engine for your startup, okay, odds are your users are not giving you explicit ratings. All you have is some sort of interaction data. Okay. And so basically, approximately 2000 to now, people have been really thinking in this space, how do we really take advantage of all this implicit feedback? So the importance of implicit feedback, you get what I'm saying, which is like, I have some app and all I know is views, or all I know is clicks. Okay. Or I think someone mentioned before, like maybe I have like dwell time. Like I know how long you spent on a particular post. Okay. And usually what happens is we have like, I don't know, it's 100x. We have orders of magnitude more of this than we do of, let's say, ratings or stars or whatever. Right? This is way bigger than that. Okay. And so because we have all of this, we want to take advantage of this. Okay. But the issue is sometimes there's like the signal is kind of like in conflict with itself, right? Sometimes I dwell a lot on something because I'm pissed off. I don't understand something. I'm frustrated. Okay. I'm in this stupid app and I don't understand. Why won't it do what I want it to do? Okay. And so if you think dwell time, like how long I spent on something is good because it like shows engagement, then you might end up optimizing your platform to be more frustrating for people. Okay. Instead of optimizing on, their sort of happiness and enjoyment. And, you may discover that like your customers don't return. Okay. Because you're optimizing on the wrong thing. Okay. But the main thing is we have way more of this implicit feedback. Okay. And so I showed you that like baseline model, right? We're going to take the average rating of all the users and all this stuff, but you don't have ratings here. You don't have ratings. So you can't do any of that. Okay. And so you're stuck. So I'm not going to give you all the details about this, but when you go into those Python libraries that I will post, that I showed you at the beginning, okay, you're going to find several of them. They're, if you go through them, they're going to say, okay, we implement item collaborative filtering. You'll say, I know what that is. Check. Okay. Many of them will say, we implement Bayesian personalized ranking. Okay, for implicit feedback. That's what this is. Okay. So this was came out in 2009, I believe. And this was, again, sort of like a shockwave for dealing with implicit feedback. Okay. And it's sort of the foundation for a lot of our modern methods. So if you grab one of those packages and you're goofing around with it, try out BPR. Okay. And if you can crack and understand BPR, you're living the dream. Okay. But what I'll do right now, because I'm going to wrap up in just a few minutes, I'll just give you the flavor. Okay, the flavor of BPR and like why it's cool. Okay, so the main idea is this. Okay, look what I got on the left-hand side there. We've already seen that. That's just users and items in a big matrix. Okay, but usually what happens, this is all we know is we don't know in this case if the user liked the thing. All we know in this case, let's say, is that they clicked it. So let's say it was pluses or like they clicked. Right, that's a click. No, that's not a dick. That is a click. Okay, we got a lot of those. Okay, we got a lot of clicks. So if you do any of those models before, we might say, well, if I didn't click here, does that mean it's like a 0? Like I didn't like it? Well, if I didn't click something, does that mean I didn't like it? It could mean that. It could also mean I never saw the thing, right? Or, you know, I wasn't engaged by it. I didn't click it. It doesn't mean I didn't like it. I might like it. I just never clicked it, okay? So in BPR, the big idea is say, look, in implicit feedback, I can't tell you if this user prefers 2 to 3. All I know is they clicked both of them, okay? The big assumption is just, I'm going to assume everything you clicked on, you prefer to everything you did not click on, okay? So that's the main like intuition. I prefer items that I have interacted with to items that I have not interacted with, okay? But for all those items I didn't interact with, it could be because I didn't view them. It could be that, you know, I didn't like them, but we don't know. Okay, all I know is that things I've interacted with, I prefer to things I did not interact with. So once you've gotten that big intuition, you're going to understand BPR, which is basically then going to use that matrix factorization I talked about a minute ago to try to solve it. Okay. Again, I'm not going to show you the details of that because I want to finish, but it's super cool. Okay. So I want to wrap up with this. You've been a great crowd. Thanks for sticking around. All I want you to do to get out of this is like, look, recommenders are super cool. The basics of them are, I hope you'll find, totally doable. Okay, not complicated at all. Lock those down, because once you've got that, then as you're doing your machine learning, then as you're learning some fancy TensorFlow model for whatever, you'll be able to connect this sort of fancy new stuff into these fundamental ideas, okay? So where do you want to go next? What are some hot things that are happening that are super cool in this space? So things we did not talk about. One of them is sequential recommendation, right? Everything I've talked about is kind of like, do you like this thing or not? But everything's sort of fixed and static. But really, it's more like sequential recommendation is, you know, I watched this movie, I watched that movie. What will I watch next? So the sequence of things is very important, okay? So I'm just trying to give you some phrases. So if you're interested in that problem, it's called sequential recommendation. You have a related idea called session-based recommendation. This is usually kind of anonymous. And it's usually like a short session. This would be like, you know, you log on to some website, you click, 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 right? So that's like a session. Doesn't last very long. And it's similar to sequential. What do I recommend next? Okay. But since it's anonymous, usually anonymous, I don't have like a user profile. I don't know who you are. It's really short, which means I've got to be fast. I can't goof around and try to build some fancy model in the background. It's cool. Another important area people are working on is it's called explainability. Okay. So this is like, hey, why did you recommend this thing to me? Okay. I'm a recruiter for a company, and the algorithm told me to look at these 5 candidates. Why? So I want the recommender to tell me, we like this person because they have a CS degree from A&M and a GPA greater than whatever. Okay, cool. So I want to learn that. I want to know that. So I want to be able to inspect and ask questions of it. So that's called explainability. Okay, super cool. Another one is conversational recommenders. If you think about like Alexa or Siri, or even just, you know, we're still trying to build these things, which are, they have aspects of natural language. They have aspects of kind of a back and forth dialogue. But the idea is, you know, hey, what should I listen to next? No, I don't really like that. Could you give me something that has more danceable? Okay, so you can imagine kind of having this back and forth dialogue. And so how do you model that state and how do you update the recommendations like that? Super cool. The next one is just a little trickier. I'll skip over that. Basically, how do you kind of do some of this machine learning in practice? This one is modeling context. So basically, like when you build recommender, right, it's not just the fact that like, oh, you're clicking and viewing and what do I tell you next? It's more like, where are you? What time of day is it? What are you doing? Are you with your friends or are you with your parents? right? You think about like, what should Netflix recommend to you on a Friday night with your friends versus what Netflix should recommend to you on a Sunday afternoon with your parents, right? So context matters, right? And how do you infer that context? How do you use that context? Same thing like if you have any kind of smart assistant on your phone, right? It's like when I look at my phone in the morning, it needs to know like where I am. I'm at home. It's the morning time. I'm about to commute to work. So then it's going to recommend maybe some route, right? Or it's going to tell me something about the traffic. And so it's really hard is to figure out context and to do it right. Because if you do a bad job of it, I'm never going to use it again. This point here is just about challenging data types. So this is more like people are getting excited about new things, like for example, like a podcast, right? Because podcast is audio, right? So totally different, or health information. So people are wearing their Apple Watches, their Fitbits and stuff like that. And so you might have all sorts of like heart rates. You could have other accelerometers. You have lots of things that make it kind of different and very challenging. Last thing is all the bad stuff. And so I tried to sort of emphasize everything that's sort of positive, but there's a lot of bad stuff. Okay. If there's bad stuff, that means there's opportunity. Example, this is from a couple of years ago about Pinterest. I think they fixed this a little bit, but on Pinterest, like if you, depending on how you click, they had very aggressive personalization. Okay. So if you clicked for anything that was like vaccine related, within minutes, you would be down this rabbit hole of conspiracy theory and just like total insanity. Okay. And so that's an example of, in theory, a good idea, personalization, machine learning, learning user preferences, but turned up to 11, that it leads you down to some bad pathway. You see something similar with YouTube, right? So a couple of years ago, like Sundar and folks were brought before Congress because basically, YouTube's recommendation algorithms are figuring out people are figuring out like or excuse me, are basically like taking you on a pathway by recommendation from sort of a safe, normal thing. So, hey, you might like this thing. Next thing you know, it's like you're suddenly in this like this dark, dark place. In the chat, Daniel's posted on here, yeah, about this. There's a classic article about how Target figured out a girl was pregnant. Yeah, so there's lots of companies know a lot about you, and they're trying to constantly learn a lot about you. And in one sense, that can be a good thing, right? They're can personalize and give you better deals or give you better products. But on the other hand, right, they could be potentially misused or abused. So it's really, really critical issue. Okay, that's all I got. I got all these great resources here. I hope you can take a look at them. I'll make sure that I post these slides into the Discord, or we'll figure something out to do that. Other than that, I really appreciate your time. Of course, I'll take questions in the chat. You can ping me in the server, or you can email me or whatever. Yeah. And I'll look in the chat right now and answer some questions. Thanks, thanks, folks. Question: how well do you think the level of explainability has kept pace with complex algorithms? Yeah, explainability is not doing great. It's really hard to do explainability right. Thanks, folks. Appreciate it. Yeah, I hope I get well soon too. Thanks. And there's a forum, folks. Fill out that form, give some feedback. I get feedback on myself. This dude sucked. Don't invite him again. Yeah, so explainability is tough, right? And so sometimes they do it like, it's pretty simple. It's like, oh, we're recommending this to you because 3 of your friends liked it, okay? Or like on Netflix, they'll say, we're recommending this movie because you liked this other movie. Bye, thank you guys, appreciate it. And that's okay, but explainability is just a really hard thing to do, and to do it in a useful way for people. There's a lot of research in that space right now, so check that out. Yeah, thanks everybody, appreciate it. Bye, bye. Thank you. Where's the guy who was in Malaysia for joining us? That's amazing. Yeah, thank you all. I hope I get better soon too. Appreciate it. Good luck with your datathon. I'm going to be judging tomorrow, so knock it out. Okay, do a great job. Cool. Yeah, I'm done. Thanks. That was great. Slides, you want me to put them on? I can just drop them in there, I guess.
If you could, that would be